All right, guys and gals, it's time for Ellipses Part 2. So we talked about how to graph an ellipse last time. Now we're going to talk about how to write the equation of an ellipse. So same formulas. You have your center just like it was with the circle. It's got to equal 1. A is underneath your, whichever way is your major axis is going to go. B is underneath your minor axis. Remember, A is greater than B. So the distance for from the center to the vertices is A. Distance from the center to the co-vertices is B. And to find your foci, C squared equals A squared minus B squared. Same thing, nothing new there. But instead of graphing the ellipses, we're going to be given the graph or be given information and generate the equation. So let's jump right into it. So here we go. We've got a nice little graph here. First thing, we're going to figure out what's the center. So difficult on this one, isn't it? A nice 0, 0 here. From there, we're going to well, it asks for the vertices, co-vertices, and foci, so let's just figure them out. So the vertices, well, which one's bigger? Let's see, 1, 2, 3, 4, 5, 6. Well, one of them is 6. 1, 2, 3, 4. So A is 6, B is 4. So my vertices are going to be on the x axis. They're going to be horizontal this time. So 6, 0, and -6, 0. If you have your center, remember, your vertices are plus or minus A. Co-vertices are plus or minus the B on whichever axis you're dealing with. So co-vertices are at 0, 4, and 0, -4. So all you really need to actually get the equation is A, B, and your center. However, just want us to list out the information, so let's do it. To find out our foci, we'll have to use our formula. You know something? Yep, it's A squared minus B squared. So make sure you're putting it in the right order, because if you do it backwards, you're just going to get all kind of messy issues. So C squared is going to equal 36 minus 16, which is 20. So C equals the square root of 20. That's 4.5-ish, I believe. Let's get a decimal. Square root of 20 is 4.5. Yep. We're just going to go to one decimal place. Foci are always on the major axis. In this case, it'll be the horizontal axis. So 4.5, 0, and -4.5. 0. Now, the equation. Well, our h and k are both 0, so it's just going to be x squared and y squared. We know it's got to equal 1. My major axis was horizontal, so underneath x squared, I need a squared, which is 36. Underneath y squared, I need b squared, which is 16. So again, we didn't actually need any of this to find out this equation, but that's what it wanted, so let's do it. Not hard to do anyway. Let's try another one. So again, the center is 0, 0. So we can start with, we know it's going to be x squared, y squared. That's going to be 1. Let's figure out A. And I can tell just by looking at it that it's going to be vertical here. 1, 2, 3, 4, 5, 6, 7. B is going to be 3. There's our equation, done already. Vertices again, if we know our A, B, and center, we can just say, oh, hey, my vertices are on the major axis. It's going to be the vertical one. So my x value is not changing. And it's going to be 0 plus 7, 0 minus 7. You can check. Sure enough, it's at 0, 7, 0, negative 7. For the co-vertices, the y value won't change because it's horizontal. We're going to have a plus and a minus 3. Again, the center is 0, 0, so that makes it easy for us. Foci, it's going to be 0 something. So let's see, 49 minus 9, that's 40. So C is the square root of 40. That's a bit less than 7. .3. So since it's 0, 0, makes it nice and easy, positive, negative. Okay, keep going. Okay, and one more interesting now. We have 3, negative 6, if I can count. Let me double check that. 1, 2, 3, 4, 5, 6, yeah. Down here. Anyway, so that means x minus 3 squared, y plus 6 squared. It's got to equal 1. So now we can count. Obviously, it's going to be a horizontal ellipse. I can see it's going to be 1, 2, 3, 4, 5. A is 5. B is 1. So that's going to be 25. And 1 squared is 1. So I guess we could simplify this part a little bit. I'd take this. I'm not going to worry about it. But technically, it would be more like this, y plus 6 squared with nothing else. Okay, and that's going to be square root of 24, which is practically 5. .9. Okay, so here's the more interesting part. To actually list these points out, you could, just go 3, negative 5. That's one of my co-vertices. But let's go ahead and use a property that the center plus or minus A and B and C gives us our vertices, co-vertices, and foci. So let's see. My major axis is horizontal, so that means my vertices y value will be the same as the center. Okay. Co-vertices x value will be the same. Now, our x value for the center is 3. A is 5, so that's going to be a negative 2 and an 8. Let's check that. Negative 2, that's 1, 2, 3, 4, 5, 6. And then 3, 4, 5, 6, 7, 8. It worked. Co-vertices, same thing. So we're going to take negative 6 plus 1. That's hard. And minus 1. For the foci, again, it's on the major axis, so the y value will not change in this case. So we're going to take our x value, head up the way. I'm going to subtract, and I get negative 1.9. Change that to addition. get 7.9. And there we go, we've got it all filled out. Let's do one more graphing. Oh, or not. Okay, well, easy enough, right? I mean, you just get the points, write them down, fill it out. It's easy stuff. Now, what if we're given just vertices and covertices? What do we need to find the equation of the ellipse? We need the center, we need A, we need B. Well, we can figure out A and B because we know the distance of the major axis between one vertex and the other is 2A, however that goes, whatever. And to get B, it's 2B from covertex to covertex. What about the center? Oh, let's look at a picture. The center is right in the middle of either our covertices or our vertices. So we're going to use the midpoint formula. And it doesn't matter if you pick the vertices or covertices to get your center. Either one will work just fine. I'm going to go with my vertices, and if you can't do that in your head, I'll write that for you. So remember the midpoint, we add our x values and divide by 2. We add our y values and we divide by 2. That's 0, 0. Now to get A, we can either realize it's the distance from vertex to center, which you should be able to kind of see, or we could take the distance between the vertices and cut it in half. I think it's easier. We got the center. Let's use it. So since we're only dealing with horizontal or vertical ellipses, yes, I did that backwards, then we're just going to either subtract the x values or the y values. We could use the full distance formula, but there's really no point. So I can see from my center to my vertex is 5. From my center to my covertex is 2. How'd you get that? Well, that's 5, 0, and that's 0, 0. So how do I get from 0 to 5? I go 5 units. How do I get from 0 to 2? I go 2 units. And we don't need our foci. There's no reason for it. From here, we can get our equation. X squared plus y squared, both of those are going to be over something, equals 1. Well, let's see, which one's bigger? Well, the x's. The distance between the x's is bigger than the distance between the y's, so my a is going to go on here, 25, a squared, and b squared. And there's my equation. Easy as pie. 4.15926, yes, that one. All right, so here, again, it looks like 0, 0 is my center. We use the center formula, but I mean, if that's a 0 and that's a 0, 0 plus 0 is 0 divided by 2 is 0. Those are opposite, so 0. Okay, center 0, 0. Okay, again, it looks like my vertices, it's from 0 to 8. That's A is 8, B is 6. I went further on my y's, so it's going to be a vertical ellipse. That's 64. That's 36. That's x squared. That's y squared. And that's a 1. Nothing to it. Okay, these might be a little more interesting. And yes, you might notice, since we're doing only horizontal and vertical ellipses, for one of them, the y values are going to be the same. For the other one, the x values are going to be the same. So that's going to be my center. Or we could do this midpoint formula. -5 plus 1 divided by 2 gives us, oh look, -2. 1 plus 1 is 2, divided by 2 is 1. So that's another way you can just look at it and get your center. Now let's figure out A and B. This time our center is not 0, 0. So for my A, it's on my vertices. So how far did I go to get from -2 to -5? I went 3 units. How far to get from 1 to 3? I went 2 units. Now which one's which? Well, my vertices, the x values change, so it's horizontal. This time we have x plus 2, y minus 1. And there we go. Easy as that. A couple more examples. What we got? Oh well. Guess I'll do them. They're easy enough. So again, what stayed the same here? The x values did. That means this is going to be a vertical ellipse. The y value stayed the same here. A, let's see, to go from 1 to 8, I went 7 units. To go from 5 to 11, I went 6 units. And again, what stayed the same on the vertices? The x did. So this is a vertical. If the x stayed the same, the y changed, so that makes it vertical. X minus 5 squared, y minus 1 squared, 49, 36, and it's got to equal 1. So ladies and gents, this should not be too difficult for you. Okay, the y value stayed the same. So my y value is going to be 6. It's going to be a horizontal ellipse. Oh, notice this one. What does it give us? It gives us the foci instead of the covertices. But now we have to do a little bit of work. So I know my center is going to be 6, and I can go ahead and figure it out with the midpoint formula. 0 plus a -10, and I divide that by 2. -5. So now we know what A is. A is going to be 5, right? To go from -5 to 0, we went 5 units. We don't know what B is. We can figure out what C is, though. C is 2. I'm sorry, 3. To go from -5 to -8 is 3 units. Pythagorean triple there, B's got to be 4. Let's just do the math. So C squared equals A squared minus B squared. So 9 equals 25 minus B squared. Move that over, we get B squared equals 16, and sure enough, B is 4. 4 units. So I could figure out my covertices now, but we already have our center. We have A, we have B, we don't need to find out our covertices. We can just write the equation. So if they do give us the foci, it takes a little bit of work. But not that much. So the major axis is x, and that's going to be a 25. That's going to be a 16. A squared, b squared. Okay. So again, first thing I did was I found my center using the midpoint formula. I realized that the x changed, so it's going to be a horizontal ellipse. That means A has got to go underneath the x's. It gave us our foci, so I used that to figure out what my C was. My distance from center to the foci is C. This is the formula we know that relates A, B, and C. Plug in the numbers and just solve for B. Keep going. I guess the last one's going to be using the foci. Okay, so x value is -9. Well, because that's what it gives us. So my y value, I'm going to use the midpoint formula. -2 plus -12 divided by 2 is -7. And I can figure out that A is 5. Okay, so let's go ahead and write down what we know for sure. So already we know it's going to be x plus 9 squared. We know it's going to be y plus 7 squared. We know it's got to equal 1. The x values didn't change here, so it's a vertical ellipse. So that means this is going to be a 25 down here. So all we're missing is the b. Well, from here we know that c, we don't know what b is. We do know that c is going to be 4. Another Pythagorean triple. And a's got to be the big one, right? That's another 3, 4, 5. Just like, is that the same thing we just did? Oh, 5, 4, 3. Okay. So I can tell you without doing any work whatsoever, b is going to be 3. That's 9. I'll show you though, just so you don't be like, where'd that come from? Geometry, people. Geometry. And remember, even if we're looking for b, it goes there. So we're pretending we don't know that that's going to be a 3. 16 is equal to 25 minus b squared. Swap it around, b squared equals 9. And sure enough, b is 3, like I told you. I won't guarantee that they'll always be. In fact, they shouldn't always be nice like that. Hopefully the next one will be an example where it's not. Let's find out. All right. We're given the co-vertices this time. So look on the previous examples. Vertices, vertices, and that one gave us both, right? Yeah, okay. This time we're given the co-vertices. So we know the y value is going to be 0. The x value changed on the co-vertices. That makes this, what kind? Well, the y values got to change on the vertices, right? So there you go. It's going to be a vertical ellipse. So 0, 0, well, that's too easy. And it's another, okay, so A is 13, okay. Another Pythagorean triple there. So x squared, y squared, I made these too easy. So A, we don't know. We do, it's 13. B, it's got to be 5. C is 12. So what's changing? The x's are changing. That's my co-vertices. So B goes underneath the x's. B squared. C squared equals A squared minus B squared. So 144 equals A squared minus 25. 169 is A squared, so A is 13. Which means this is 169. Sorry. So hope they just keep giving us nice ones. Let's see. Can't tell yet. Let's see. So 2, and then let's go ahead and use the midpoint formula, -1. 7 plus -9 divided by 2, -1. All right, that's my center. This is my co-vertices. The y value is changing there, so my b's got to go on, my b squared's got to go under y's. So y plus 1, x minus 2. Again, it's an ellipse, so that's going to be a plus. A, we don't know. B is 8. So that makes this 64. I guess 3, 4, 5 times 2. Let's see. So to get here, it's 6. Yeah, so A is going to be 10. They made them all too nice. I don't like that. So you can do the formula, or you can just know your Pythagorean triples. $36 is equal to a squared minus 64. 100 is a squared. A is 10. And there we go. Let's look through the homework and see if there's any that are more interesting. I want one that doesn't have a Pythagorean triple. So I guess we can just bear with me. So that's the whole lesson. If you want to stop it now, go ahead. I'm just going to see if there's any interesting problems here. Okay, so the foci. So it's going to be -3, and that's going to be what, 12. So it's 5, 12, 13, I bet. Yeah. All right. Well, I'm going to pause it, and if I find one more interesting, I'll do it. If not, then the end. See ya. All right, so it's not quite as interesting as I was hoping for, but we'll do it. It's got a square root in it. So this is number 9 from the homework. Center, that's going to be -4, 0. Point formula. So A is 7. B, we don't know. C is going to be square root 13. So now it is possible for B to be a square root. That's what I was hoping to find, but we didn't. That's okay. Same thing applies though. So C squared equals A squared minus B squared. So 13 square root squared cancels. Equals 49 minus B squared. Switch things around a little bit. B squared equals 36. So B is 6. So again, I was hoping to get a nice nasty square root there, but we didn't. So we found B is 6. We've got our center. We can get the equation. So this one is what's changing. The vertical is changing on the vertices. So it's going to be a vertical ellipse. Oh, done. So nothing to it really, guys. Just plug in the numbers. I mean, midpoint formula and counting is all you got to do, really. So this is the end. The end. Goodbye.